Hello everyone, and welcome to today's webinar entitled Perform Elevation Analysis and Network Analysis in ArcGIS Online. My name is Jonathan Van Dusen, and I am a higher education developer analyst working in the Education and Research Group out of our Toronto office. Some housekeeping items before we get started. When you joined the webinar, you were prompted to join the audio broadcast. To listen in, you have two options. One, to dial in using the toll-free number provided on screen, or two, listen in using your computer speakers or headphones. For the best view of today's presentation and any demonstrations I'll show, click the full screen button on the WebEx toolbar to put the presentation into full screen mode. At any point during the session, you can click the big blue arrow to return to the default view. Throughout this session, if you have any questions about the content being presented, please use the chat window. Be sure to choose my colleague Cameron Plouffe from the list of users to contact, then type your question in the box and click Send. Please feel free to type your question in at any time, or if you would rather email me offline, I will have my contact information on the closing slides. Also, this session is being recorded. The recording and presentation will be made available after the webinar. By the end of this webinar, you will hopefully have gained a greater understanding of the ArcGIS Online platform, which is quickly becoming a powerful platform for spatial analysis. In this webinar, we will discuss how specific analysis tools can be accessed in ArcGIS Online and how they can be applied to solve spatial problems in urban planning and hydrology analysis. We will also discuss how these can be included in your own web applications using the Web AppBuilder for ArcGIS. Let's move into our first section and make sense of where these analysis tools fit compared to existing tools in the ArcGIS platform that you may already be familiar with. If you attended my colleague Ian Greensmith's webinar last week titled Summarize Your Data and Perform Hotspot Analysis in ArcGIS Online, this material will be familiar, but it is worth reviewing before we continue. The ArcGIS platform has many different components. You may have seen this graphic before in previous Esri presentations. We see that the desktop and the server, traditionally where our GIS workflows are performed, are part of a broader ArcGIS platform that also includes web, mobile, and online services. At the center of the platform is a cloud. This is a portal, such as ArcGIS Online or Portal for ArcGIS. While ArcGIS for Desktop is still a common tool for performing spatial analysis, a lot of the same analysis tools you are already familiar with on the desktop are now available in ArcGIS Online. For this webinar, we'll focus on the following toolsets from ArcGIS Online: Use Proximity and Analyze Patterns. These toolsets contain the network analysis and elevation analysis services we will be discussing. Future webinars will focus on different toolsets and workflows, and I will provide more information on these at the end of this webinar. You will need an identity to access analysis tools on ArcGIS Online. You can think of an identity as like an online passport. In this case, it's a username and password you can use to access and interact with online content and tools from multiple devices, as demonstrated by the diagram from the previous slide. Your identity is associated with a role, and your role has specific privileges. There are some privileges that relate to spatial analysis, such as creating items, such as uploading shapefiles or other spatial data, and publishing these as hosted feature services. As well, specific premium content privileges are available depending on what you or your students are trying to accomplish. These include access to the spatial analysis and network analysis services. For this webinar, we will assume that you have sufficient privileges to be able to perform analysis, either through a publisher role or a custom role assigned to you by an administrator. Just to quickly comment on credits at this stage, Service credits are the currency used by ArcGIS Online services to perform specific tasks. You can assign credit quotas for a particular named user, group of users, or role, which is ideal for managing classes and class assignments. In ArcGIS Online, analysis tools are most commonly accessed from the map viewer. We see here a screenshot of the analysis toolbox in the left-hand panel of the map viewer. However, some of these tools can be accessed directly from ArcGIS for Desktop and ArcGIS Pro. In ArcGIS for Desktop, these are available as My Hosted Services and Ready-to-Use services. The My Hosted Services section provides access to your online content, and the Ready-to-Use services section provides access to some of the analysis tools. This screenshot shows the ready-to-use services available to me, including many of the tools that I'll be demonstrating today. Next, in ArcGIS Pro, the latest addition to the ArcGIS for Desktop suite, these are built into the Analysis tab. This contains a palette of available tools, a portion of which are shown here, and a separate drop-down box with network analysis tools. ArcGIS Pro is built with web mapping in mind, so you will be able to access the suite of tools here as well very easily. As well, analysis tools can be accessed in Portal for ArcGIS, which is similar in functionality to ArcGIS Online but is installed on-premises. Portal for ArcGIS can be configured to use utility services from ArcGIS Online based on an ArcGIS Online identity. Finally, ArcGIS apps like GeoPlanner or custom-built apps through the Web AppBuilder for ArcGIS can use these analysis tools as well. We will see an example of this later in the webinar. Now that we have covered how to access these tools, let's move on and discuss how these tools can be used in research. We'll start with the network analysis capabilities. In performing elevation analysis and network analysis with ArcGIS Online, one major difference compared to typical desktop workflows is that the elevation, hydrology, and network data are already provided as part of the analysis services. That is, the data have already been prepared for use and can be included immediately in your web maps and your analysis. For network analysis, street coverage is available for most countries worldwide, though the network services available differ somewhat between countries. For Canada and the US, most of Europe, and many other countries, the highest level of detail is available, including complete road data, historical traffic data, and live traffic updates every 5 minutes. This is the top level in the list shown. This can be helpful if your network analysis takes into account the traffic at any given time of day or week. For other countries, only limited street coverage is available or some other level of detail along the spectrum here. Please see the links at the bottom for more information and to view the Esri World Traffic Service. This is a layer that you can add to your web maps and view interactively the traffic at any given point. Network analysis tools within ArcGIS Online mostly consist within the Use Proximity toolbox. This toolbox contains the following tools: Create Drive Time Areas, which is similar to creating service areas in ArcGIS for Desktop; Find Nearest, which is similar to the Closest Facility tool; Plan Routes, which allows you to solve a routing problem with destinations and any number of vehicles that need to meet the destinations; and Connect Origins to Destinations, which performs an origin-destination analysis, connecting all pairs of origins and destinations. As well, the Find Locations toolbox, which we'll be looking at in more detail later, contains the Choose Best Facilities tool. This is similar to the Location Allocation tool in ArcGIS for Desktop, which allows you to choose ideal facilities from a set of candidates based on nearby facilities, travel times, and capacity. So compared to traditional ArcGIS workflows, there are a couple differences here. For example, in ArcMap, you would perform each of these analyses by first creating an analysis layer, such as a route solving layer, and then adding input points or lines like for your destinations or for barriers, and then solving the routing operation. Here, the tools are run directly without creating an analysis layer first, and the input is configured within the tool itself. As well, as mentioned before, all of these tools access the network services discussed on the previous slide. The net result of both of these factors is that not only do you not need to create your own network data sets first, you can get started very, very quickly in actually performing network analysis in ArcGIS Online. From these tools, we will specifically look at the Create Drive Time areas and Find Nearest tools. As well, for this demo, we'll be looking at an urban planning scenario for the city of Vancouver, British Columbia. This demo includes data from the Vancouver Open Data Catalog, licensed under the terms available at this link. So I'm going to switch to my web map right now in ArcGIS Online. And here I have the details page for the web map, so I'll go ahead and open it in the map viewer. If you haven't used ArcGIS Online, this is really the main part of the program where you'll perform your cartography, your web mashups, whatever sort of analysis you want to perform. You can add layers to the map here, you can save the map, you can share it within your organization, you can share it publicly or privately, you can share it using a web application, using templates that are available, a wide variety, or the new Web AppBuilder for ArcGIS. And you can also change the base map. Right now I've got it set to the dark gray base map, which is very good for doing mashups of several different types of data, like I'll be doing in this demonstration. If you haven't used ArcGIS Online before, I'm not going to go into too much detail about how specifically to use it right now, but just to focus on the separate analysis tools we'll be looking at. So to start off here, I've got a web map of the city of Vancouver, and all of these points here are public libraries within the city. I've configured the pop-up so you can click on the library and you see the name of it as well as the address, and there's a link you can click on to go to the specific web page for that library branch. So let's say that we're doing an urban planning analysis, maybe we're working for the city, and we want to find what would be good suitable locations for a new library branch. And some of our criteria might include that the branch needs to be accessible by foot within a reasonable walking time, and that it should also be located close to elementary schools. Say, for example, there might be after-school programs happening at these libraries, or the schools might want to go on field trips. So we're interested in walking distance, and we're interested in proximity to schools. So the way I'm going to start this analysis is by using the Drive Time Areas tool I mentioned earlier. And that's from the Analysis Toolbox here. You can find that in Use Proximity, and then Create Drive Time Areas. So we start off with our layer of libraries, and then from here we can choose what sort of routing analysis to perform. We see different travel modes here. By default, it selects driving time, and if you choose driving time, then you can choose the traffic that it takes into account. It could be live traffic for the current time that you're doing the analysis for. You could predict further into that day. Again, this depends on the particular region for which you're doing your analysis. Or you can look at historical traffic patterns. This isn't relevant to what I'm doing right now, though. I'm interested in walking time, and that doesn't take traffic into account. So let's say that this is sort of like the buffer tool, where you can create buffer polygons around a particular point, where you can have one buffer that is within 5 meters, one that's in 10 meters, and they're nested inside of each other. So here I'll set the different walking times that I want to consider. I want to have one ring that considers 10-minute walking times. Outside of that, I want to have 20-minute walking times, and then 30-minute walking times. So I'll get some polygons that will hopefully span across most of the city so I can see which areas are well served by libraries within the walking times I'm considering. And we can have these polygons overlap with each other, but here I'm going to dissolve them, and then I'll set a suitable name. So here it says travel from Vancouver libraries, and it specifies the different times that I've specified. I can save it as a layer within my organization, within a folder that I've set, and I can restrict it to only the map extent that I'm looking at. So if I'm only interested in these libraries, I could leave this box checked, and it would maybe take a bit quicker to run since it's considering fewer input features. But for my current analysis, I want to look at the whole city, so I can either zoom out, or leave this unchecked. But as it happens, this analysis operation takes a couple of minutes, so I've gone ahead and created this already. So I'll go back into my table of contents here, and I've created all these drive time areas. So we can see the lighter polygon around each school is associated with the 0 to 10 minute walking time range, and then outside of that we have the 10 to 20 minute range, and then the darkest spots are the 20 to 30 minute walking ranges. So this is good, but then what if I also want to bring schools into the analysis? So I've got a schools layer I got as well from the Vancouver Open Data Catalog, and I'll load that in. And this is a little cluttered, but what I'm more interested in right now, if I zoom around the city, and you could do this in a more sort of statistically robust fashion, looking for areas like with a lot of schools that tend to have higher walking times. And there's a botanical gardens around this area, so it might not be a suitable place like to build a large new development. But then looking around the rest of the city, we see this area here, which has relatively high walking times, the 20 to 30 minute polygon, and there's several schools that are clustered around this area. So maybe this is one of my candidate locations for a new library branch. So as a city employee or as an urban planning student, I could do a detailed site selection process that considers lots of different factors for where a new library should be placed. And what the various different demographic areas are in the city, what the current service is like. At the moment, I've identified one particular area within the city that has an empty lot that could be suitable for a new library development. So if we're in the middle of our polygon right here, I've changed the base map type to the imagery base map. So now we can see this empty lot here, right in the middle of our sort of quote-unquote dead zone where the traffic, where the walking time is higher. So I'll edit my library's feature layer. I'll use the editing tool here, and I'll create a new library feature. I'll zoom into this little lot here, and again, and this is just for demonstration purposes, you would want to do a more detailed analysis. I'll drop this new point here, call it candidate library, and then close. So I'll change my base map type back to the dark gray canvas, so we can see that this point now exists along with all the other libraries. So now what we could do, we could consider the driving time from each school to the existing libraries. And I've done this already, but I'll show you the tool. It's the Find Nearest tool. It's like the closest facility tool in ArcMap. So I can choose the schools that are closest to particular libraries, create a route from each school to each library, or to the closest library, I should say. Do this based on walking time, and we'll limit, these default limits are fine. We only want to choose one nearest library for each school, and 100-minute walking time is much more than we need, so we'll leave that the way it is right now. But again, this network operation takes a while to run, so I've gone ahead and done it already. And if I turn on this travel time layer, we can see the connections between each school and each library. So this school, for example, this clump of schools in the middle, we can see how long the travel routes are to get to the existing libraries. For this school, for example, Laura Secord Elementary, it's a 27-minute walking time and 2.26 kilometers, so about a mile and a half of walking time. So our candidate school location could work well in this area. So I'll zoom out, I'll turn off these line layers again. Again, each of those lines represents a route from a school to the closest library. I'll turn off a couple of layers. I'll focus on the schools that we've got right now, but then I'll regenerate my drive time areas. So that's, again, in the Analysis tab, use proximity, and then create drive time areas. We'll use the same settings as before. We'll do the walking time, 10 and 20 and 30-minute polygons, dissolve the polygons so they don't all overlap with each other. And again, this takes a minute to run, so I'll switch back here and show the one that I've already created. So we can see how that new library that I've created affects the drive time polygons. This is the set of drive time polygons with the new library added, and this is what it looks like without it. So we can already sort of get a sense of how this is going to change the travel times when we bring in the schools. So let's rerun our find closest facilities tool, which again in ArcGIS Online is the find nearest tool. And we'll do this based on our schools and then to the closest libraries. We'll use the same settings as before, and I've created this already. So now our new set of lines, we can see for the new school we've created, the travel times are much shorter from the schools to whatever their closest library is. They've got a much closer library now to service them. So based on this and whatever other criteria we want to consider in our site selection, we could maybe recommend this new library location, candidate library, as a suitable location. Laura Secord Elementary School, which previously had a 27-minute walking time, now we can click on this little route it's created. We see that that's dropped down to a 7-minute walking time. So if we'd identified that particular schools had too long a walking time to libraries, then this new candidate location could be useful for that. So that concludes the network analysis workflow that I wanted to demonstrate, and I'll switch back to the PowerPoint presentation. Next, let's look at the services available in ArcGIS Online for elevation and hydrology analysis. As with the network analysis services, these services use ready-built datasets, which in many cases can save you the effort of downloading and preparing the data yourself beforehand. Please see the links on this slide for more detail about the data available worldwide. In particular, for elevation data, the sources are the United States Geological Survey and the Shuttle Radar Topology Mission, as well as the General Bathymetric Chart of the Ocean. The highest resolution available is for the continental United States, although all regions have a choice of resolutions available, and you can choose between these different resolutions when you're doing your analysis. Maybe a certain scale of elevation data is more appropriate than another, depending on your study area. The hydrology data is sourced from the U.S. National Elevation Dataset, as well as the HydroSheds product from the World Wildlife Fund, the USGS, and several other organizations worldwide. These data have been hydrologically corrected, with sinks filled where appropriate. Again, please check out the links on this slide for more information about the datasets. Finally, elevation layers such as hillshades and aspect rasters are available for inclusion in your web maps. See the link at the bottom. In ArcGIS Online, the Find Locations toolset contains tools that create new spatial features based on given criteria. 3 of these are useful for elevation and hydrology analysis. The Create Viewshed tool returns the areas on the ground that can be seen from a given vantage point given the height of the observer and the height of the ground features. The Create Watersheds tool returns the areas that drain down to a given set of points. And the Trace Downstream tool returns line features representing the flow path from a given set of points. As well, two other elevation services are available using the ArcGIS Online API: Elevation Profiles and Summarize Elevation, the latter of which creates a chart explaining, for example, the slope along a certain line that you provide as input. These tools can be accessed using the ready-to-use services in ArcGIS for Desktop, as shown earlier, or they can be accessed directly by their service URLs. From this tool set, we will look at two tools specifically: Create Watersheds and Trace Downstream. As well, for this demonstration, we'll be looking at stream gauge locations from the province of Ontario, near the town of Port Hope, east of Toronto. This demo includes data from the Ontario Open Data Catalog, licensed under the terms available at this link. So I'll switch back to ArcGIS Online now, and I'll go back to my content. I've got the web map here containing the stream gauge locations that I want to work with. And as before, I'll open this up in the ArcGIS Online map editor. So I've already loaded into the web map the various stream gauge locations throughout the province of Ontario, and I've zoomed into a particular study area. So from the stream gauge data that I've got, I can click on one of these points and I see the name of the river that it connects to, roughly what the location is, how long it's been in service. So I'll go back to my analysis tools, and then I'll go into the Find Locations toolset. And from here I'm going to use the Create Watersheds tool, and this will generate a polygon for the watershed for each of these flow points. It contains the area in which the water flows down to each of these points. So I will choose this stream gauge layer as the one that I'm interested in, and I can set a search distance in case each of these points isn't directly connected to the drainage network. Maybe there's a slight misregistration between the points and the ArcGIS elevation and hydrology data. So now I'll save the result like with this name here, but then I've already performed this since it takes a minute, so I'll switch back to my table of contents. And after letting it run, you would receive a layer that looks something like this. The green points indicate the little adjustments that it performed between the input points and the ArcGIS Online elevation sets. So for each of these watershed polygons, I can click on it and see the area of the polygon, as well as all the attributes that are brought over from the flow point that it connects to. For example, point 753 here, that ID number corresponds to that particular flow point partway along the Ganaraska River. I can pan around here as well, and I see this small watershed too, and this is associated with a particular tributary for the Ganaraska River. So this flow point represents a stream gauge, and that stream gauge monitors the water quality just for that small tributary, and the rest of the watershed outside of this little polygon drains down to this flow point. So this is good, but in terms of how to apply this, what if I were working in a hydrology lab, for example, and we were responsible for a set of stream gauges, and we wanted to find suitable locations for a new stream gauge. So we could create points, as I've done right now, and then create create watersheds around them. But then if we wanted to turn this web map into a collaboration tool, we could save it. So I'm saving the map back to my ArcGIS Online content, and I'm going to create a web app for it using the Web AppBuilder for ArcGIS. I'm going to share it within my organization, and I'll click the Create Web App button. Here I see all of the various different templates that are available to me, but I'll switch to the Web AppBuilder tab specifically. So I'm going to go back to the PowerPoint right now and explain more about the Web AppBuilder. So the Web App Builder is an easy-to-use, what you see is what you get tool for creating web applications on the ArcGIS platform. These apps can include web maps and analysis tools. The Web App Builder includes templates, themes, and widgets for customizing the look and feel and the functionality of your web application without needing to write any code. There is also a developer edition of the Web App Builder that allows you to develop your own widgets to add your own functionality. ArcGIS Online analysis tools can be included as widgets. You can configure these widgets to include options for your app's users, such as allowing users to save their analysis results back to your ArcGIS Online organization. It's important to note, however, that the other users of the web map must have sufficient privileges to use these analysis tools too, as described at the beginning of this webinar. So we'll continue with the previous demo. I'll go back to ArcGIS Online. I've got a good name for the app here, and I've got tags here, and these are fine, so I'll continue. And from here, it loads the configuration area for the Web App Builder for ArcGIS. On the left-hand side of this window is where you can configure the layout and the themes for the web app, as well as the certain analysis functions. On the right, it shows you a preview of what the web application is going to look like once you're finished. For example, here we can see various different themes, and we can change the layout of where these widgets, these are locations where we can place widgets. We can change the location on the screen where these are positioned. I'll stick with this default position up here. We can also change the color of the web app as we see fit. We can also go in and change the logo and the title. But you can see that it's brought this directly from the web map that I was creating. It's using the same extents, the same layers, the same symbology. I can click on one of these points or one of these polygons, and it contains the same attributes as I was looking at before. So if I want to add more functionality to this, I can use the widgets. And I'll click on this little widget container here, which is associated with the one that's highlighted in red at the top left corner. So I'll choose a widget. This is a measurement widget that's built in. So I can configure parameters here, and then when the user clicks this, they have a measurement widget that allows them to measure distances on the map or for areas. But I want to add one that corresponds to my ArcGIS Online analysis. So I'll click this widget container, click the analysis widget, and what we see here when we continue is the entire list of analysis functions that are available in ArcGIS Online. So for this demonstration, we've already created watersheds, so I'm going to do the trace downstream tool. And if we wanted to configure more options for this tool, such as whether users could save data back into their organization, like this checkbox here, then we can change these settings here before we continue. So now here we can see that the point is that the tool has been added to the map, and I'm going to save this web application, and I'm going to launch it now outside of that app configurator. So now let's say that I'm analyzing these watersheds, and I want to view the flow locations, the flow directions for a point within one of the watersheds that I'm interested in. So I'll click this point, this button on the screen, and this allows me to drop a custom point on the map. In ArcGIS Online, we've been creating features based on layers on the map, but within the tools as well, we can create layers based on arbitrary points. So I'll create a point there, and currently my scale is about an inch on my current monitor corresponds to 1 kilometer, and I already know that this watershed here in blue connects to this flow point here. I just want to see the path that it takes to get to that point. So I can set a maximum distance for this trace, let's say 30 kilometers, which is probably more than we need. Let's go to 20. If I don't set a maximum distance for the trace, there's a very good chance that the downstream trace line that it generates is actually going to flow all the way down to the ocean, and that's beyond the scope of our current analysis. So we're only interested in our particular study area, so we can generate a polygon that says where to clip the output line to. So we'll specify this polygon. And now we can continue and we can run the analysis, and it gets saved to a new layer within our organizational account. So this will take a minute to run, and when it does complete, there will be a new feature that's added to the web map and a new layer that we can manipulate within the table of contents in the web map, which is, we see a legend here and we see a layer list where we can toggle the visibility of individual layers. So we'll go back now, and it's finished generating this line. So I'll click out of this Legends widget and the Analysis widget, and we see the downstream trace line that is generated from our origin point, and we can see that as expected it flows down through this flow point at the end of the watershed. We can see the length of the trace output line, and we can also see which particular data set, which hydrological data set was used to generate it. As I mentioned, since we're in Canada, we need to use the HydroShed's 90-meter data set, which is provided as the default for outside of the US, where a 30-meter resolution data set is available. So that's an example of the sort of analysis that you can perform within the Web AppBuilder. We could share this app within our organization, allow other users to create their own features. We can collaborate on them. We've turned a web map into a collaboration tool very easily. So now I'll switch back to the PowerPoint and start to wrap things up. So to sum up our discussion today, there are a number of tools available in ArcGIS Online that you can use for elevation and network analysis research. Specifically, we discussed select analysis tools available in the Use Proximity and Find Locations toolsets, which together allow you to perform terrain, hydrology, and network analysis in ArcGIS Online. We also discussed how these tools access ready-to-use datasets from ArcGIS Online, allowing you to perform analysis quickly without necessarily needing to prepare data beforehand. Finally, we saw how the ArcGIS Online analysis tools can be added as widgets in the Web AppBuilder for ArcGIS, allowing you to create custom applications for your analysis projects. With the concepts and examples shown today, you should be able to apply them to your own project work. As well, a great starting point for resources that we talked about today is the online Esri help documentation. Esri is quite good at communicating any planned changes so that the user community stays informed. Each update to ArcGIS Online also comes with a detailed list of changes outlining the new tools and capabilities available. The second link, Perform Analysis, contains a list explaining all the analysis functions available in the ArcGIS Online map viewer and how they can be used. Also, be sure to visit the desktop analysis page at the bottom link. This contains case studies that demonstrate how analysis can be performed using ArcGIS Online and ArcGIS for desktop. For some Canadian examples developed here at Esri Canada, check out our lesson planner. Here you will find a wide range of learning resources that relate to the tools that we have discussed today. Whether you are looking for desktop, online, or solution-focused resources, you can use the Lesson Planner's search tools to sort through and quickly find a learning resource you can use. As an example, the second link leads to a tutorial for summarizing data and creating hotspots in ArcGIS Online, similar to the previous webinar. Please feel free to check out all of these links, as well as the ones posted on previous slides in regards to the data sources for ArcGIS Online analysis. So on behalf of Esri Canada, I want to thank you for attending today's webinar. Please feel free to contact me if you have any questions. And Cam, there's been a question. So there was a question about the availability of these data sets. And the data sets are available worldwide. As I mentioned, for the street network, the coverage varies depending on the country. For the US, for Canada, for lots of other countries like across Europe and, switching back to that slide. For the USA, for Canada, for most of Europe, for other countries such as Australia, India, there's a few countries in South America, you get the highest level of detail available, which includes live traffic updated every 5 minutes, predictive traffic for later in the day. For some countries, mainly less developed countries, you might only get a minimum level of street coverage. So the coverage that's available is worldwide, but depending on the country that you're looking at, it'll be somewhere along this continuum where the live traffic is the highest level of detail. I should also note that for the travel methods that we were able to select between in ArcGIS Online, the travel modes, such as walking and driving and trucking distances, these will affect your routing too, because for some of the roads in our network data sets, which are on ArcGIS Online, the road might be marked as being blocked to trucks or being blocked to vehicles that only have a certain number of axles, for example. So if you're an ArcGIS Online administrator, you can customize the travel modes. You can create new ones based on these certain criteria that you need for your network analysis. If you're a student, you can access the network service you want to use in ArcGIS for desktop as a ready-to-use service, and from there you can configure the travel modes in more detail. And all of that relies on the level of network coverage in this data set. There was another question about integrating your own network data, your own data. Well, okay, before I get to that, in terms of the elevation data, this also is available worldwide. So for all of these areas, you have access to this worldwide data that's listed here. The US has more detailed data available from the United States Geological Survey. And it's a similar story for the hydrology data. Anyway, there was also a question about integrating your own data sets. And say that you have a network data set, or if you've got your own terrain layers and you want to use those with ArcGIS Online analysis. That isn't possible. However, if you have an ArcGIS server instance, then you can create your own geoprocessing tools that use the network data set that you've created or the terrain data set that you've created. You can create a geoprocessing tool that references that, publish that geoprocessing tool on your own ArcGIS server, and then you could create a reference to that tool within your ArcGIS Online subscription. You can even add that geoprocessing tool as a widget in the Web AppBuilder, though that was outside of what I showed today. If the service has, if it's accessible by a URL for a REST endpoint, and then you can specify the URL within the Web AppBuilder or any other custom application that you build, and as long as you've got the right permissions to use that service, then you can also access that throughout the ArcGIS platform. Any more questions? Okay, well, I think that covers everything for today. So again, thanks for attending. If you have any further questions, please feel free to email me at that address, jvandusen@esri.ca. And again, thanks for attending.